making things a little bit more challenging now. Take a look at this guy right here. Something bugs me about this. I don't know about you, but it's bugging me. Think about it for a second. We're normally going through a circle like this all the way around to pi, then to 2 pi, but you know and I know that we can keep on going. That would be 3 pi, that would be 4 pi, and so on and so forth. That'll be 5 pi. Oops, we got the pi there. 5 pi, that would be, right? That keep on going. The 6 pi and so on and so forth. My question then to you is, look at this guy. This guy says 10 pi over 3. Hold on a second. That means if you think about it in terms of 3, there's 3 pi over 3, right? That would be 3 pi over 3. That would be 6 pi over 3. I've gone over. 10 pi over 3 has gone over, but by how much? Well, let's keep on going. That's 6 pi over 3. Over here, add another 3 pi over 3, so that would be 9 pi over 3. So that must tell me that 10 pi over 3 has got to be right here, baby. There's 10 pi over 3. Now, why did I go here, not in this section? Because remember, those are all pi over 6s. Pi over 3s are these guys. Aha! There's our 10 pi over 3 right here. Now, think about this. All of these guys have coordinates of 1/2 root 3 over 2. And it's up to you to figure out what the sign of those guys are. Easy. Add sugar to coffee. Oh, that means, okay, the only one that's positive is 10. So if I do the 6 trigonometric ratios for that, this becomes really, really easy because I go here, down to here, okay? That's a negative x. That's got to be a negative y. So that means our coordinates here have to be, yep, you guessed it, -1/2, negative root 3 over 2. There's our coordinates for that. So with that in mind then, okay, let's go out. We stated the reference angle. Reference angle is right here. So that's got to be, well, think about it. We went from 9 pi over 3 to 10 pi over 3. So my reference angle's got to be pi over 3, doesn't it? Okay, now I got to do the 6 trigonometric ratios. Okay, let's write those. There you go. And now let's determine. Remember, it's only tangent that's positive. So this guy here is going to be positive, and its reciprocal are also going to be positive. Every one of these is going to be negative, right? Now, remember sine. Sine 10 pi over 3, which we're here, is, oh, there it is, root 3 over 2, and it in fact is negative as we predicted. So cosine then, oh, as we predicted, -1/2. Okay, now since we know that this is pi over 3, and pi over 3, since we've done this 100 times, we know 60 degrees. So honestly, watch how easy this is if I drew this as 60 degrees, there's 30 degrees, there's my right angle triangle, 1, 2, root 3. So easy if you do it this way. The tangent of 60 degrees is going to be opposite over adjacent. So opposite is going to be root 3, adjacent is 1, positive 1. So the reciprocal of that is going to be, yep, you figured it out, 1 over root 3. Don't forget, multiply by root 3. This is going to be root 3 over 3. And it's in fact going to be positive because the original tan was positive, right? Okay, so let's do the secant. The secant is going to be the flip of this guy, -2 over 1, or just plain old -2. And then the cosecant is going to be the flip of this guy, okay? Which of course is going to be -2 over root 3, or, oh, there we go again, rationalizing, okay? This is going to give you -2 root 3 over 3. There you go. That's how you do it, okay? So let's look at the next question, which is down here. Oh, this ought to be a little bit more interesting. Again, we're dealing with going over the 2 pi's. But by how much? Just sit on the circle and do it. You know that this is 0, but you also know this is 2 pi, but we're dealing with 6's. Okay? So if we go backwards because it's negative, because that's what we've got here, this is pi over, oh yeah, 6 pi over 6. That must mean that this is, of course, 12 pi over 6. And check this out. If we add all the way back to here, we're going to be at minus 18 pi over 6. So we've gone too far. So bring it back, a pi over 6. That's right here. There's our negative 17 pi over 6. Reference angle, of course, is going to be pi over 6. Huh, that was simple. Well, of course it is. Makes sense too, doesn't it? And if you think about it, pi over 6 is the thinner guy. That's the guy, it's the shorter guy right there. All right? And you know that every one of the coordinates for that are going to be root 3 over 2, 1/2. And since this is add sugar to coffee, you know that again, it's going to be our tangent, which is positive, everybody else is negative. So let's throw in those trigonometric ratios. Put in our signs based on the fact that tangent is positive. So it's going to be a positive value there. That's going to be a positive value there. Okay, the rest of these are all going to be negatives. Interesting, interesting. Note that this guy is here. It's part of our short rectangle. So this guy, in fact, is going to be negative, negative, right? So negative root 3 over 2, right? Negative 1/2. Perfect. Let's go to town. Okay, sine, negative 1/2. Cosine, negative root 3 over 2. Root 3 over 2. There we go. Tangent, we'll figure that out in a minute, right? Cosecant, flip it. That's going to be negative 2. Secant, flip the cosine. That's 2 over negative 3, which of course multiplied by root 3, both sides. This is going to give you negative 2 root 3 over 3. There's our secant. And now let's figure out our tangent. Our tangent, of course, we might want to use the special triangles. You know and I know that's based on, well, what is pi over 6? Pi over 6 is, in fact, 30 degrees. Okay, let's draw a nice little triangle. Here it is. There's the 60 on the bottom. There's the 30 on the top. 1, 2, root 3. There it is. Now, okay, so tangent of 30 degrees is opposite over adjacent. So this is going to be 1 over root 3, or the cotangent, oh, I spelt it wrong. That's supposed to be cotangent, okay, is the flip of this. This is going to be root 3 over 1. Now, don't forget, you can't have over root 3. So multiply that by root 3, multiply that by root 3. We end up with root 3 over 3. Isn't that pretty? You betcha. So they take a little while, but you know what? It sure beats throwing it in their calculator and not getting the right answer, right? Okay, so let's do these ones. Let's see if we can do these ones a little bit quicker now. Okay, same thing. Got to be able to bounce back between degrees and radians. So let's go. Obviously, you're way over. So 360 degrees is all the way around to here. There's 360. Now, how much over are we? I don't know. So why don't we just go 570 degrees minus the 360. Let's see what we have left. 0. That's going to give you 1. That's going to, oh, I'm at 210 degrees. Now, where is 210 degrees, though? Well, think about that. That's 180. 210, hey, that's right here. We did this one already. We did this one. We know that we're over here by 30 degrees. Well, that's exactly what I did in this last part of the podcast right here. So I know, and you know, let's do this quickly. Here we go. That's going to be the narrow one. Okay, each one of these is root 3 over 2, 1/2, according to our studies on the unit circle. So this one's going to be negative, negative. So this is negative root 3 over 2, negative 1/2. Okay, we're looking for the cosine. I could rest assured and say that this guy is actually negative root 3 over 2. Oh my goodness, check the cast rule. Add sugar to coffee. Yup. It better be negative. There it is. Look at this one, sine pi over 3. As soon as you see the 3, you know automatically we're going to be dealing with this guy right here. Okay? But where is negative pi over 3? Okay, let's draw our unit circle. Negative pi over 3. right? If this guy's pi over 3, negative pi over 3 has got to be here. And there's our reference angle of 60 degrees. Oh, how sweet. Okay, so that must mean that this is all in the coordinates of 1/2 root 3 over 2. That means positive, negative. So this is positive 1/2, negative root 3 over 2. Okay, looking for the sign of that? No problem. That works out to be negative root 3 over 2. Look how quick you can do these now, right? Pretty neat. Okay, 16 pi over 3. So we're based on pi over 3s now, okay? Not pi over 6s or pi over 4s, or pi over 3s. Recognize that pi over 3s are going to be these guys, right? So let's go. Let's do it, okay? So 16 pi over 3, where the heck is that? Well, you know what's interesting here that you can do is just divide it out. If you think about it, 3 goes into 16 5 times with a 1 over 3 pi left. Now, you really don't care about the 5, do you? Okay, that just means that you've gone 5 pi over 3. So go 5 pi's. So there's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, and go 1/3 of a pi more. Okay, that goes down to here. There's 1/3 pi right there. There's the point that you're at. Well, that's simple enough to do. And you have to remember that all of these guys are 1/2 root 3 over 2's, which you know is negative, negative. So that makes this guy right here negative 1/2, right? Negative root 3 over 2. Okay, you have to find the cosine of that. Simple. Cosine for that is going to be negative 1/2. Oh, it's actually getting kind of easy. Okay, oh, look at that. Another nightmare. But again, you're dealing with 6s. So if you're dealing with 6s, think about our beautiful, right? It's going to be the short and wide one. So where is this? Okay, let's divide this out. Okay, 16, or I should say 19 divided by 6. Isn't that, right? Negative 3 and 1/6 pi. So go back 3 times, 3 pi. There's 1 pi to here. I'll do it in a different color. Hold on. There's pi, 2 pi, negative 3 pi, and a negative 1/6 more, which has got to be that guy right there. Okay, so if we draw that out, okay, let's clean this up a little bit because we don't need this to distract us. Okay, you know and I know that this is talking about this guy right here. Okay, so think about it again. Starting here, there's pi, 1 pi, negative 1 pi, negative 2 pi, negative 3 pi, plus a little bit more, which is our pi over 6. Okay, so that's that point right there. Okay, that's good enough. You know that each one of these points is root 3 over 2, 1/2. But according to add sugar to coffee, you know that the sign is the only positive one. Prove it. Okay, negative, up, positive. So this is going to be a negative root 3 over 2, positive 1/2. Beautiful. Okay, you're asked to find the tangent of that. Well, granted that that's tangent, it's kind of tough to do, but really, pi over 6, if you remember, pi over 6 is just our 30-degree one. Okay, so draw our special triangle. Okay, there it is. There's 60, there's 30, 1, 2, root 3. And once you get the hang of this, what's really cool is you're going to memorize this. Just by doing enough questions, you end up memorizing them all. All right, so we want the tangent of this guy, which is 30 degrees. So there's your 30 degrees opposite over adjacent. Toa. So this is going to be equal to, and remember, sine's the only positive one here. So our answer is going to be negative 1 over root 3, or rationalizing the denominator again, this is going to be negative root 3 over 3. That's how it's done. Now, I got a couple challenge questions for you here. The challenge questions that I want to give you are these guys right down here. Check this out, okay? What if this is a sine squared? So what? Sine squared basically means the sine of 5 pi, oops, let me write it as a 5 pi, getting sloppy here. 5 pi over 6 all squared. That's what it means. So quickly, let's go because most people are getting tired here. This is 6 pi over 6. So you know that this guy is going to be right to about here. That's going to be the narrow one. Okay? You know that these guys are all root 3 over 2s and 1/2. This guy's going to be negative positive, so negative x, positive y, right? So this is going to be negative root 3 over 2, positive 1/2. You want the sign of this guy, so this is 1/2, so this is actually 1/2. And then you're going to square this, is going to give you 1/4, and there's your value. Huh, okay, so how about for this guy? Can we do it for this guy? Same nonsense. Remember, this is the sine of 3 pi over 4 all squared plus the cos of 3 pi over 4 all squared. Question is, where is 3 pi over 4? All right, let's draw it. Perfect. You know and I know that right here is 4 pi over 4. So guess what? If we're going all the way around, 3 pi over 4 has got to be right here. And that's one of those pi over 4 ones. So this, in fact, is going to be negative, positive, negative x, positive y. So if it's one of the pi over 4 ones, that's going to be negative root 2 over 2, positive root 2 over 2. Okay? So the sine of this guy is going to be root 2 over 2 squared plus the cosine of this guy is going to be negative root 2 over 2 all squared. With me? Okay, so let's square this. Well, that's easy. That's going to be 4. The square of root 2 is just 2. The square of negative root 2 is just 2. The square of that is going to be 4. Add them together. 2 and 2 is 4. All over. Wait a second. What? What? It equals to 1? Yeah, no kidding. Why? A squared plus b squared equals to c squared. And you know, and I know, your c squared, your c, is the radius of a unit circle. It's in fact 1.